Well, hello. I thought I'd just do some of these problems for you to kind of get you ready for the big test on Monday or Tuesday, whatever your final is. All right, so let's begin. Number one. So number one, we're looking for the diameter. So we know the circumference. So circumference equals pi d. Circumference equals 94.24 equal to 3.14 d. Divide both sides by 3.14. And I have my trusty rusty calculator right here. 94.24 divided by 3.14. 30, about 30. And we want to do feet. Pretty cool. All right, number two. So number two is looking for the circumference. Circumference, if we know the radius or if we know the diameter, we can find it. So the circumference is equal to 2 pi r. We can say that. So our goal here is to figure out what r is. Well, what do we know? We know this little section right here is the arc length. And we know that the arc length, GH, is equal to theta over 360 times 2 pi r. Ooh, there's the r. So let's fill it in and solve for it. Then we know that the length is 5.5. We know the angle is 35. 360 times 2 times 3.14 times r. So what I'm going to do is I'm going to put all these numbers together, get a number, and then divide both sides by that, and life should be good. Okay, I got about 0.611 r. I'm going to divide both sides by 0.611, and I'm going to get 5.5 divided by 0.611, and I get about 9. So r equals 9. But I'm not done yet because I need to find the circumference. So I'm going to plug that right into here, and that's going to be 2 times pi times 9, or 18 pi. I'm going to leave my answer exact like that. That certainly works, or I could multiply 18 times 3.14 and be done. Hey, number three. Number three is a lot like number two. We're really just going to use this formula right here, the arc length. So AB is equal to 115 over 360 times 2 times pi times the radius. And that's going to be equal to a number that I think you can plug in. Hey, number four. Number four looks like a good one. Got a mountain bike tire, so mountain bikes are awesome. Diameter of 26 inches, great. They make 29 inch. I know I have a 27.5, so different sizes for different feels. To the nearest foot, how far does the tire travel when it makes 32 revolutions? So just find the distance around it, multiply by 32, and that'll be the total distance it goes. So the circumference is equal to pi d equal to 3.14 times 26. So 3.14 times 26 is 81.64. And now we're going to multiply that by 32. And we get 2,612.48 inches. Okay, so that's the total that we've gone. And what's going on with inches then is it says to the nearest foot. So we just need to divide that by 12. Divide by 12, and we get 217.7 feet. So if you have that tire, you put that little we used to put baseball cards or playing cards in there, and so as the spokes went by, it would make like a little engine noise. Pretty cool. All right, areas of sectors and circles. Maybe I'll do a quick one of these. Notice that there's always an example on this each section. That's kind of nice. I'm going to do number 6. So number 6 is asking for the shaded region. So I see that as a rectangle minus a half a circle, a rectangle minus a half a circle. So on number 6 here, I would say the area of the rectangle minus area of half the circle. So you can write it out like that, and that kind of keeps you grounded a little bit. The area of the rectangle is 6 times 4 minus area half the circle is 1/2 times pi times the radius squared. Well, what's the radius? The radius is this length, right? Or you could say it's this length, or you could say it's this length. And remember, this whole side is 4, so that makes the radius 2. So we'll put 2 squared, because the area of a circle is pi r squared. Half of that will certainly work. So that is going to be I get 17.7. Yay for us. All right. Maybe it would be a good idea. Yeah, I think we're good. Okay, area of polygons. Area of polygons. Hey, we're going to skip some of these. I don't know if this is quite right. Let's see. Oh, that's the ones we want to do. So 11, 12, and 13. Let's just pick our favorite. Why don't we go with, I don't know, let's go with 12. So whenever we do any of these, what we're doing is we're getting this triangle and we're shooting for the area of that triangle, if we can get the area of that triangle. So maybe I look at this triangle right here. That's, if I can find the area of that, life is good. All right, so I'm going to take this down here and draw a bigger picture. We know this is 5.2, and we know this is 7.6. So this height is really important. Half of 5.2 is 2.6, so we know that already. A couple different ways to do this. What we've done in class is really focused in on this angle. Okay, so how do we get that angle? We have to go up there and count the number of sides. So 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So if we take 360 divided by 9, we get 40. But 40 is the angle of the whole central angle, so we'll divide that by 2 and get 20 degrees. So this right here is 20 degrees. So then we could use SOHCAHTOA, and life's good. We're looking for this value right here, the apothem, or the height of the triangle. So we have the hypotenuse or the opposite, so we can use a lot of different things. We've been using tangent a lot, so I'll just use tangent. So the tangent of 20 is equal to opposite, 2.6 over A. Cross multiply and divide, so we get A is equal to 2.6 over the tangent of 20. I'm just going to put all that stuff in my calculator right now. 0.6 divided by the tangent of 20. And I'll just check, make sure I am in degree mode. Because if you're not, life is not so much fun. I got 7.14. So that is the height of that triangle. So now I can find the area of the triangle, and that is 0.5, 1/2, times the base, 5.2, times the height, 7.14. Multiply that out, times 5.2 times 7.14. All right, so that is 18.564. Now notice I use the whole base, so I use that. and I use the height. So the 18.64 is the area of the whole triangle. So I need to multiply that just by 9, and I get 167 about. There's no units there, so sometimes you say unit squared. Cool. All right, volumes of prisms and cylinders. Prisms and cylinders. Well, there's a nice example of a prism. So I'll go ahead and do a cylinder. So I'll do number 22 there. 22, the volume of any prism or cylinder is the area of the base times the height. The area of the base of a cylinder is pi r squared times h. So that is 3.14 times the radius. The radius here is 2 times the height, 8. So we just plug that in. 3.14 times 2 squared, which is 4, times 8. And we get 100.48 square millimeters. Square millimeters. Cool. Little hint for 23 is you need to find the area of that front base, the front pentagon. So just like we just did, really focus in on that. You're going to want to kind of draw that picture, find that angle. Half of 2 is 1, so that length there is 1. So use that, and one step at a time. Just one step at a time. You don't have to do a lot of them, just that one. Okay, volumes of pyramids. Pyramids. Okay, this is the new yesterday. Let's do, well, it's up to you. I guess we could do 25. The volume of a pyramid is the area of the base times the height. Wait a minute, that looks the same. And then we're going to divide that number by 3. That's pretty cool. So the area of the base of this one is a triangle. So that is going to be, let's just do them separately. The area of the base is going to be 1/2 times 15 times 8, which is 60. The height is equal to 20. So we're ready to rock and roll here. We put that in 60 times 20 over 3, and we're going to get 400. 400 what? Cubic yards. Cubic yards. Cool. So some things to notice there. Right there is 90 degrees. So I know this can be considered the base and the height of a triangle. So they have to be 90 degrees. And then you can use that formula, 1/2 base times height. Yeah. All right, it says surface areas. Don't worry about surface areas. We're just doing volumes of cones. So I tried to make that all legit for you. So let's try 30. Let's try 30. 30 gives you, well, it's a volume of cones. Let's write down the equation of a cone. So volume equals area of the base times the height over 3. Area of the base is pi r squared times the height over 3. And we know some stuff. 3.14. The radius is 16, so we square that, times the height, which is 30, divided by 3. So what about this? Why did they give it to us? Because they could. Not necessary for the volume. Not necessary for the volume. Maybe, ooh, look at this. What if they didn't give you that 30 and you knew this is 16? Then you could use Pythagorean theorem to find that height. So that might be something to notice. Hey, we plug stuff into our calculator. 3.14 times 16 times 16, since it's squared, times 30 equals, divide by 3 equals, we get 8,038 cubic centimeters. I believe that's it. So good luck and I will list all the solutions for all the problems so you can have that. All right, not bad, 15 minutes.